Good morning, everybody. Thanks, Heinrich, for the introduction. So I'm SRE, head of platform, and that's what I have to manage with my team. So we run our infrastructure in AWS and Google Cloud across various regions, and that's also what keeps me awake all the time. That's kind of just a brief overview what our infrastructure looks like and the application that we need to run and all the components. So we are an observability platform. So we process OpenTelemetry logs, metrics, traces, web events, that kind of stuff. And as you can see, it's a nice mix of Golang, Python for AI services, Java for some business apps, a Node.js in there, and some Next.js frameworks, things like that. So nice mix of applications, and it just keeps growing and growing. And as a startup, so we're 2.5 years old now, speed is really critical to have a chance to compete with the other observability vendors out there. So for us, it's really important. That's one of our main focus as well last year, to release early and often, especially now that we move more and more customers. They have feature requests, they find bugs, and we want to get them polished out and released as soon as possible. So we all agreed within engineering that we need fast deployments, we need reliable platforms. And yeah, as an observability vendor, we also need to make sure, especially as an SRE, that it's reliable. You know, you probably all know when running things and deploying things, things can break, right? You deploy new code. So our customers depend on the platform, so it needs to be more reliable than what our customers run. And over the years at the various companies I was before, there was always this gap between what's passing in CI doesn't always mean that it's also working in production. And just a few examples, as our backend engineers now, they typically have unit tests, integration tests, they use test containers. It all works nicely on their notebooks. It works on the CI environment, but somehow in production things still break. Then front-end engineers, they have their test frameworks, they have their end-to-end tests. You can run them all in CI, but still things break. And as SREs, now we have all our alerts, we have synthetic checks, we have all our tests in place. But that doesn't mean that things that worked in development or that they carry over one-to-one to production. So that's also what we were facing. So that's just what our CI pipeline looked like last year, while we were still, how do you call it, stealth with the design customers. So we were that's just the GitHub pipeline, right? So we are open API first. So all the components, they somehow always need to talk with each other, no matter if they're Golang or Java apps. So we have open API spec files where we generate all the types. Then we build and test all the components, run all the tests. We deploy everything using Helm charts, so we have tests for that as well. Then the containers are built, pushed to ECR, we release the Helm charts, and then last step is to always deploy to dev. And we have one mono repo, so everything is in there. Once you merge your PR to main, it automatically gets pushed to development. That was all fine. And front-end engineers on the side, I learned at some point they also had like this Playwright end-to-end pipeline that was mostly red, but it existed. So just keep that in mind. And then deploying to production. As an SRE, I love automating things, and since, I don't know, Jenkins 2005-06, that was my go-to CI tool back then. Now I switch more to GitHub Actions for convenience. I was always automating things, right? So production deployment, we had 3 regions and Marcel back then last year. It was just the press of a single button, everything was automated. It was working nicely. But there was this release document that people were supposed to go through. Everybody could press that button, but they were supposed to check that things were fine in development, right? So check logs, traces, click through the product, make sure that nothing was broken. And the more and more we developed new features, that list kept getting longer and longer. And at some point we ended, like it was in September last year, we had like only 1 or 2 deployments a week because nobody wanted to press that button. And it was kind of getting annoying, so we had to change something. And last year, at a different conference, I heard a talk from a German government agency, and they had a very similar setup. After the talk, I can share you theirs is open source. They're the same technology, a little bit smaller product, but the idea is carried over quite nicely, and I will show you what we did. So the first step stayed still the same, right? Now we have just 24 components, so doubled since a couple months before. All the initial steps are the same. We are also pushing now to Google registry, the container images. That step is completely stayed the same. But the pipeline got longer, you see that on top. So the first thing we did, so we introduced these quality gates. And that means, there's 6 steps. And if any of these steps fail, the production deployment is automatically stopped. So what that means is, the moment you merge a PR to main, it gets automatically now built and also deployed all the way through to production if everything is green in this pipeline. And the first step, so I mentioned we use Helm to build or to deploy everything, and we use ArgoCD. So the first thing we do is we have this little GitHub wait timer. It's a feature in GitHub where you can say wait for 15 minutes or 20 minutes before you trigger the next step. And the first step is we have 3 different Kubernetes clusters in development, one in GCP and the other 2 are in AWS. Make sure that this version, this tag, that all components, 25, 30 components are deployed with this tag and are up and running. So that's the first check. So we know that the code has been running, has been deployed. If you know ArgoCD, it takes a while now for it to pick up new configs, like a minute until the reconcile loop and the sync completed. So this just makes sure the code is running and has been running for also a few minutes. So caches are filling up and things like that. So first step, quite simple. The second step, we use Checkly we use -0 to monitor ourselves, but it also makes sense to check certain things from the outside. Because if your own alerting is broken in development because somebody broke something, you will not find alerts later on, right? So we use Checkly for that. For the basic functionality, we have Playwright tests that go through the main navigation items and make sure that they all work. And we use heartbeats for certain things that we expect to happen in certain intervals, sync of certain billing data or some other things. And the next step is actually the one that has the most value for me and for us. So this step is pretty much using our own monitoring and our own alerting to verify that nothing is broken in development. So what that means is all our alerts, so we use Prometheus alerts, all our alerts, that's roughly 150, I checked this morning, are always identical between dev and prod. So as an SRE platform team, we have a list of alerts for all components, data stores, the infrastructure, Kubernetes, whatever we use. And we sync them via infrastructure as code across production and development, across all environments, so they're always identical. And we make sure that none of the alerts are failing. And since we are using OpenTelemetry, that means we can alert on logs, traces, metrics, web spans, synthetic checks. If any of these things are failing, this would stop here. And since we deployed all the latest code, we've waited 50 minutes, all the components are running, and if they are crashing, then the alerts would have triggered by then. And all our alerts, they have labels for priority, so P1, 2, 3, 4. And if P1 or P2 alerts, these ones are critical. If any of those are failing, then it stops here. So, and that also, the nice thing here is now when somebody develops a new component, new features, and something is crashing, we update the alerts, or new component is added, they also need to add new alerts. And we can test these alerts in development then as well, and they automatically get carried over to production. So the quality of our alerts improved quite a bit using this approach as well. The next thing that I really like, so for OpenTelemetry and the semantic conventions, there's now a CI/CD section as well. It's still, I think on stages development, but it's a lot of this keys and are already defined what they should look like. So there's this GitHub action, for example, that we use, and what it does, it exports all the GitHub action workflow steps as traces. Yeah, so in our case, we send them to 2 different environments, dev and production. That's how we do cross-monitoring for some things. So I have all the information about the whole pipeline, all steps as a trace, and that's what it looks like. So you have each step, each build, this whole pipeline is, the root is the CI/CD workflow name, and then every single step, if you have a matrix build, then you will have a lot of steps, is a span. And then you can see the duration of each span, you can see the error codes if it's failing, and a lot of the details. And that's also what we alert on. So since we can do simple Prometheus alerts based on traces, if any of these steps fail, it triggers an alert. And then there's a nice little side improvement. That's also what we use to optimize the overall time of our builds and deployments. Because as you can see here, it's very easy to spot the steps that take the longest. And then you can check if the checkout action actually needs to check out the whole repository, or if it just needs to get the latest tags, for example, the latest commits. So that's actually quite useful. And there's various GitHub Actions out there. This here on the top right, that's just the one that we use. And we also updated a bit to comply with the semantic conventions. And but there's others as well that you can use. The last quality gate, and the one that's the most fun, is our end-to-end tests. So what we do here is the first step generates OpenTelemetry data, always the same data set. So we know what data to expect later on when we run the tests through Playwright. And yeah, as you can see in the second step, we run against Chromium, Firefox, and WebKit, test all the product features. This middle step, everything is parallelized in there. And then, unfortunately, we had to, for testing third-party integrations, we had to pull it out into a serial separate step because of API rate limits. So if you run matrix builds or want to parallelize things to improve the build times, it's nice, but if rate limits keep you from running things in parallel, then yeah, that's kind of what you need to do, or what we had to do. Yeah, and then the last bit is simply just deploying everything to production. So we do it staged. We deploy to the smallest region first, and then we rate between each one, also verify then the alerts in production if any of them start failing, and we do a rolling update automatically. And then the last step is deploying the front end, and the very last step is just sending a nice message to Slack so everybody knows the new version that gets deployed. Since there are a lot of talks about AI here, I also want to share quickly how we deploy our AI services and how we manage them, because they are not in the monorepo. And the main reason for that is the workflow is a bit different there. There's the part where you develop code, but there's also a lot of time spent on the experiments, on the testing, on comparing the test results. And what we use there is, so all AI services are in a separate GitHub repo, but flow is kind of the same. We use MLflow for managing all the whole machine learning life cycles. So you can think of it as version control for all the models. And so it logs all the training runs, the hyperparameters, the metrics, code versions, artifacts. So the things that we configure from the outside to tune the models. And then this now is an example for our AI log parser. So you can see in the screenshot, you can see how we compare 3 different runs where different parameters and settings were used, so hyperparameters. And then there's 3 attributes, or KPIs, I don't know what you want to call it, that are most interesting for us. So high specificity. So if it generates false positives when enriching the data, the accuracy, so if the result is actually correct, and the sensitivity. So if it catches all the logs that have, for example, a severity in them hard-coded somewhere, and extracts that correctly into OpenTelemetry semantic convention attributes. Yeah, so pipeline on top is similar. In this case, it's a Python app, unfortunately. It's just what you have to deal with when you use AI, build AI things nowadays. yeah, we automatically deploy the latest code and the model which is included, or the model configuration, to development. We also have quality gate checks to verify that the code is up and running, or the components up and running, that nothing is crashing. And then at this last step, we then have specific alerts for each AI service or AI component that is running. And for the log parser, the most critical one is the patch coverage. So if it sees logs, that it is able to patch them and extract attributes, severity, timestamp messages, attributes, and so on. And our alerts currently are configured to trigger, the alert goes into degraded with if it's less than 90%, and to critical if it's less than 85%. So, and that's just prompt QL there. No? It's just a regular alert. And we have a few of those for each service. And if that's fine, then we deploy the new code with the new models or new updated model artifacts to production, also to the different environments. Lessons learned. So for us, these production deployments, they weren't as scary anymore. I mean, for me, they weren't, but like for the developers, they weren't supposed to be scary anymore, so they can now focus on building stuff. We used all the things we already had and then also updated them to improve or to make these deployment decisions now, or to stop deployments to production. And our end-to-end tests are actually used now and much more stable. So I'm not sure how many of you have to deal with Playwright browser tests. They are a pain, and for various reasons. And now actually, once they fail, people need to fix them. Otherwise, their features will not go to production, or their bug fixes will not go to production. So the end-to-end tests will not pile up more and more errors inside, but they will actually get fixed quicker. And to do that, we also send a nice message to the engineering channel. When they fail, we say which browser failed, and so they get pinged automatically. All the platform and SRE tests that we created, that we were mostly running in production only, they are now also completely run in development. Since the environments are identical and consistent, the quality of these tests also became much better. And we could throw out things that weren't needed, and so that was also good. And right now we do about 5 to 10 productions per day. That also includes just small bug fixes, right? But it just happens in the background and nobody has to do anything. The staged rollouts across environments, I think they just make sense, right? You don't want to break everything at once. And one also small thing we did on the step we did on the side, we migrated all our GitHub runners to Depot. I'm not sure if anyone of you have heard about that. If you use GitHub Actions, you can just configure Depot as a runner. They have the price. They don't charge you. They don't round up to the next minute. They only charge you by the actual time that the run took. So when you do a lot of matrix builds in parallel and they just run 5 seconds, GitHub charges you full minute each time. Depot doesn't, so costs went down also quite a bit. Yeah, this was from yesterday morning. You just want to read it. So that's an engineer asking, quality gate is failing. Is anybody taking care of it? Yeah, because he wants to get his check rule sharing feature out. Yeah, and then now Yoshi just answered, be the change you want to see in the world. And he fixed it himself, right? And the green check mark always means it's done. And that's actually, that is a perfect example of what we wanted to achieve. And I have 40 seconds. And here's an example why end-to-end tests are so much fun. If you've ever run them, Chrome, Firefox, and WebKit, sometimes they just troll you, right? So Chrome and Firefox, they have the most stable, or the best APIs out of the three. But WebKit was actually the one that was not failing. That's like the first time, that was last week. Typically, always WebKit fails for a million reasons. So we always have a bunch of retries configured. For WebKit, we have very generous timeouts. Also taking screenshots is 60 seconds. And we have a fixed viewport across the browsers just for consistency, because otherwise they just break way too often. Okay, 2 more seconds. That's my talk. Yeah, key recommendations. I think I mentioned them already. Yeah, if you have any questions and if you want to talk about this a bit, come down. One major thing we are working on now is, instead of deploying, updating everything, because the platform has just grown, is looking into things like USENIX or Turbo Repo. If anyone has experience here, please come to our booth, and would be nice to have a chat to share some experiences, so we can only deploy and update things per pipeline, right? That's the next improvement we're working on. Okay, thanks a lot.